Today's lecture is all about acids. When we look at names of compounds, if we see the word acid in the name, then we know we have an acid. When we're looking at formulas, we know we have an acid when the first element is an H for hydrogen. All acids begin with hydrogen. Acids are special covalent compounds. The reason for this is because while they are covalent, there are no metals, hydrogen likes to act like it is a metal. So there is an electron transfer between the hydrogen and the rest of the compound, which just happens to be an anion. Hydrogen can form a cation, an H+, just like the rest of its group members in the alkali metals. And when it does that, it donates an electron to the anion, and therefore we have an ionic bonding within a covalent compound. Very special case here. There are 3 rules to naming acids, and they all come from the anion. Now, why would they all come from the anion only? Well, every single acid begins with hydrogen. So we can't look at hydrogen anymore after we identify that we have an acid. So let's take a look at our 3 examples here. Please pause the tape right now and make sure that you copy down this table. You need the rules in order to work with them and learn them as we work tomorrow in class. Got everything written down? Great. So the first rule is IDE. When the anion has an IDE ending, the rule is that you drop the ending of the IDE, you add a prefix hydro. Let's see here. Oops, I'm not in my pen mode. Hydro prefix and ic prefix. And then of course you name the compound an acid. So for example, we have HCl. The H is used to identify the fact that we have an acid, so we're done with hydrogen at that point. Now we look at the Cl. Cl comes from the anion chloride. The chloride is chlorine. We drop the IDE ending and we add the prefix hydro and then the suffix IC to our base chlor, and we get hydrochloric acid. Now when we have ternary acids, or acids that contain polyatomic ions, we have to worry about our ITE and ATE endings. If the anion has an ITE ending, then you drop the ITE and you add OUS to the stem. So looking here, we have HClO2. H is hydrogen. We therefore can identify the compound as being an acid, and we're done. We don't look at it anymore. We look at ClO2. We recognize we have more than one element here, so now we're looking at our polyatomic ion list. When we look up ClO2, we find out that it's chlorite. The ITE ending gets dropped, and we call this chlorous acid. If we happen to have an ATE ending on our anion, as we do in the very bottom, HClO3, H is used, the hydrogen is used to identify the fact that we have an acid, and then we look up ClO3. It happens to be chlorate. We drop the ATE ending, we add IC, and we get chloric acid. Now you're on your own with the IDE ending, but there is a little saying that you can remember to help you with the ITE, ATE endings. It's a little saying that goes like this. Oops. I ate ick and got ate us. So I hope you quick write that down, and it will help you with your acid nomenclature. Let's take a look at our first example. Here's a picture of sulfuric acid, and it's pretty concentrated since you can see the vapor. You would not want to inhale that vapor. It would definitely burn your nasal passages and your throat and lungs. But sulfuric acid, how do we write the formula for that? We have to work backwards using our rules. Sulfuric has an IC ending. Let's take a look. Sulfuric. That means we're looking up sulfate on our polyatomic ion sheet. When we do that, we see that we have a formula of SO4 with a -2 charge. Now we know we need a hydrogen because that's what makes an acid. Hydrogen only gets a +1 charge though. So we do in fact have to worry about crisscrossing. When we bring the 2 down, we see that we need 2 hydrogens. We only ever need 1 polyatomic ion because hydrogen is always +1. So our final answer for sulfuric acid is H2SO4. And that's it. Now let's take a look at hydrofluoric acid. Here's some dangerous things that you can read about hydrofluoric acid. Hydrofluoric acid is the most dangerous acid that we have to work with. You personally will not work with hydrofluoric acid at the high school level because it is that dangerous to work with. So how do we go about writing the formula of such a dangerous acid? Well, the first thing to note here is that we have hydro and we have ic. Hydro and ic, if you look back at your table, they have the meaning for the IDE ending. So we look at our base, fluor, and we're going to add IDE to that. So we're looking up fluoride. Well, fluoride comes from fluorine, which is a halogen and gets a -1 charge. Hydrogen always gets a +1 charge when it's working or acting as an acid. When we crisscross this, we simply get HF. And we're done. What about when we want to write the name for an acid? Well, you have 3 examples from the table. Hopefully you wrote that down. If you did not, please make sure you go back to the slide with all of the rules and get that copied down in your notes. Let's take a look at this. We have this compound called HNO3. That H is an indicator to us that we have an acid. So we've now identified we've got an acid. We no longer look at the H. We are now looking at NO3. NO3 tells us, well, specifically the N and the O are both capitalized, which tells us that this is a polyatomic ion right here that we're looking at. So we have a polyatomic ion. We need to look up the name. When we look up the name off of our polyatomic ion list, we see that NO3 is nitrate. Now, if you remember, I ate ick and got ite us. The 8 gets dropped, and we write, oh, that's not it. The 8 gets dropped, and instead we substitute an IC. So this becomes nitric, and of course we have to write the word acid. Nitric acid is HNO3. Now, you technically have 6 examples in your notes at this point, 3 from the original table and the 3 that I've worked out for you. Hopefully that gives you a good basic start to writing the names and formulas of acids. We'll work on this in class tomorrow.